The sessions immediately after lunch are slow and draggy. So I hope to make it entertaining as much as I can. There's a lot of content to cover, and I'll try to quickly cover some of the experiences that we have learned the last 3.5 to 4 years. So this is not something that we have done in the 3 months, of which 1 year I just spent doing research without a paycheck. So it just shows the commitment in terms of the need for this kind of a product and category. So we all know this phone hacking scandal. I don't need to go about it. It just shows the severity and the alarmness of the problem sets around the space. Now, before I talk about unified communication security, what does unified communications mean? What does it mean? So we all know UC is a very common fuzzy term that's used to encompass a lot of different solutions. Solutions could be a combination of real-time solutions and non-real-time solutions. So real-time includes IP telephony, presence, conferencing, collaboration, IM, call control, data sharing, speech recognition, IVR, and then non would be your voicemail, email, unified messaging, SMS, and things like that. So what does it say? It says that in a typical network, you are touching a lot of different components. It's not just one component. It's not just the PBX, or it's not just SIP. So it's a combination of many applications, many protocols, combinations of real-time and non-real-time interactions. So essentially, it's not a single product, but a set of products that constitutes a unified interface with a seamless user experience. So this is just an example where the world is today. So we see, the traditional siloed stacks are all quickly moving towards cloud enablement or as web services APIs that could be integrated into as part of your business flow. Talk about Google, talk about Skype, IBM, Facebook, all this, they are adding your textual-based communication paradigms to more of web and video and unified communications-related interactions. So these are the set of apps. So apps, as you show, from PBX to IM, mobile UC, speech apps, fax or IP, IM, sharing, voicemail, soft clients, desktop sharing, unified messaging. So they're all using SIP today, but can also be SIP, Skinny, H33, or a combination of many different protocols, and increasing in complex. So what does it mean? So it means that if history repeats itself, any paradigm or a trend, if you look at web applications, there was a need for, as web applications took the growth a decade back, there was a need for a security solution very focused towards web firewall. And I've been involved in that, actually defined the web firewall category myself. And it shows that SIP has a lot of such trends similar to what a web has a decade back. And in terms of, if you look at web, email, database, and of course you see now, each of these solutions in your network, real estate, demand for a strong security solution. And this is the IDC representation that shows, as more devices, more content, more applications, more on-demand access continues to permeate inside your network, it just shows that security is an important component of that. So what does it mean? It means that PBX is no longer just a siloed environment. PBX is now interacting with your web, like click to call. It's interacting with your email in a unified messaging client scenarios. It's interacting with your presence. It's interacting with your database. It's interacting with your clients, either it's a dual mode clients or a broadband or UMAs. So it just shows that the whole concept of your network is no longer a fixed network. It's now porous. People are carrying smart devices, smart UC-enabled clients, and directly services provision from the cloud. So there's absolutely no security on that front. And so I'll talk about what are those security threats and why securing real-time applications is vastly different. So these are 5 categories that I view. One is real-time requirements we know are much more stringent than your traditional data requirements. Reliability factor, low latencies. Not to mention the security requirements itself. There's a very low tolerance to false positives. Even if one call gets dropped because of a bad logic in your firewall or in your IPS device, it's a loss of business. And so the bar is much, much stringent and much more stricter in these kinds of real-time environments. Call reattempts are not acceptable. Some of the technology requirements are vastly different as well. The DPI capabilities are needs to be a lot more deeper and sophisticated, and that your traditional firewall solutions are not able to achieve. And from the protocol side, on the stack side, it's a real-time stacks. You need to have a lot more depth and coverage on the SIP, Skinny, and H323 protocol side. The enterprise-related requirements are also different because you need to understand the interoperability aspect on the UC side, in terms of, let's say, how does Microsoft OCS works with an Avayas call manager, or a BroadSoft IP-Centrex works with a BRIA UC client. So there's a lot of different protocol. SIP is they say it's the universal standard, but trust me, there are about like several thousand different variations of different variations of that, and we are having a hard time trying to even catch up with those variations. So one of the things that we built is an automatic translation in terms of interoperability between devices, being able to auto-translate the headers virtually in real time so that the connections are not lost. And then, of course, UC and wide focus is a no-brainer in terms of the solution itself. So this is the typical diagram, like where you have your traditional enterprise network, and then you have your comms network, right? So you have your data network, and then your IP, voice, and media network. So how is it laid out? So you have your data side protected by your IDS, IPS, application firewalls, or DOS, DDoS appliances, and then on the enterprise, on the voice side, usually you have a wide firewalls or a session border controller followed by a media controller. But what happens? Your merging of voice and media into your data applications is happening. So as a result, you're getting smarter mobile UCs, much more richer collaboration, presence, conferencing, IP-enabled soft phones. So that exposes a lot of different new threats ranging from interceptions, modifications, number harvestings, call pattern trackings, media hijacking, to eavesdropping. SPIT is your spam over internet telephony, to message stealing, toll fraud. These are just a few sample of them. We have internally collected several, like 500,000 different attack threats and patterns that can be possible. So just as a quick example of some of the most common threats that we are seeing in our customer networks is, so one is this DOS. We all know about DOS. So look at what happened at Telepacific about less than a month back. The whole network came down from a distributed denial of service attack, and the network was down for about, I think, 6 hours, right? So it just shows, and these were, by the way, these were denial of service attacks coming from malicious locations, for which the strength of the protection was relatively easier. But actually, we have crafted a lot more different kinds of patterns which are what we call as low volume stealth mode DDoS attacks. Essentially, it's like a sudden bursts of traffic patterns which are well below your normal thresholds, but it can cause denial of service on, let's say, CEO's phone or any specific target that you want, and there is no way that you can detect. A normal traditional firewall has no way of detecting it, what's a genuine and what's a non-genuine, if you were to strictly go by rate-based thresholds. So I think that shows that the bar for real-time environments is much more stringent. The second one is SPIT. SPIT is, you all know, spam over internet telephony. So it's very easy, like from a laptop, you can embed a WAV file and using number harvesting, you can figure out all the legal extensions, and then with a single script, you can just flood this WAV file as an attachment to all the phones, and they all will get flooded with voicemail attachments. So we have done it in our labs. It's very easy to demonstrate that. Voice phishing is another scenario where, this is where what happened was when the Citibank credit cards were stolen, what happens is the database usually contains the number and I think the zip code, but it does not contain the 3-digit PIN on the back. The 3-digit PIN is something that the person who is in possession of the card has to manually enter. So what happened is the hackers they injected a fake IVR that mimicked the bank application, and they got an email saying that from the bank, from the caller ID spoofing, they got that this is coming from your bank, let's say some bank, and the genuine user then clicked on it, and it clicked to a call to a fake IVR. So they got into their bank automated system, and it prompted them to punch their 3-digit PIN, and they had a keylogger system on the other side which is actually tracking those DTMF digits in real time. So they could fill in that missing link by using these kinds of attack vectors to do it. Conferencing attack, this is very easy. When you have conferencing, you have ability to join and refer different participants into your conferencing sessions, and usually these participants can be anywhere in the world, and anybody with running a key enable can quickly figure out what the SIP headers are and inject himself into a live session without the moderator even knowing about it. So it's a lot of different kinds of threats that happen. Toll fraud, we all know about it. Eavesdropping, this is a little bit trickier. It's not just eavesdropping, but it's also actually RTP injection and replay. It essentially means that you are in real time sniffing the RTP payload. RTP is usually stateless, runs on top of your UDP protocol. So you figure out exactly which payload portions are what offset distance from your distance that you need to look at, and you could modify like buy to sell. You can actually modify your RTP payloads in real time if they're not encrypted, to do whatever you want. And this just shows, with all the Galileo scandals that we are looking into, this can have a huge implications if proper security measures are not employed. So just from a trajectory wise, if you look at internet where it was from 1995 to 2000, 5% penetration, and when internet became 40 to 50% penetration in mid 2000s, then you started seeing code reds, love letters, slammers, and the big ones, which resulted in billions and billions of dollars of losses. So that's where I think voice over IP, 2008, 2009 was in the 17% penetration, and we started seeing toll frauds, data to voice exploits, spam over internet telephonies, TDoS, which is the FBI released a press note on TDoS, which is a telephony DOS attack. This is different from your traditional DOS attack. This is a pretty interesting. I will encourage the audience to do a search on FBI and TDoS. Will give you all the details on how this was crafted. Voice phishing, we talked about. This affected one of the banks in Santa Barbara. Major vendors are now exposing different vulnerabilities. So essentially, caller ID spoofing, and then botnets, SIP botnets, and then voice message stealing that we saw that. So what it shows is that essentially, the prediction is that by 2012, the voice over IP will be somewhere in the 40 to 50% penetration, similar to what we have seen in the internet days, and suddenly we'll start seeing a lot more large-scale, high-profile incidents than what's already out there today. This is just a snapshot, high profile in terms of, we collect all the vulnerabilities and the attacks and threats in the open world, and we provide that as security advisories to our customers. And in terms of the different kinds of things that we see, is from voicemail hacking to networks going down to the recent report from CFCA says that the actual loss has increased. Just 3 years back, it was on 40 to 50 billion, and now it's increased by 70 to 80 billion. And what was the reason? SIP trunking. SIP trunking was directly connecting the core of the network to your totally unmanaged and uncontrolled environment that I showed you in the previous slides. And communication frauds, toll frauds, user frauds, identity stealing, denial of service attacks, all of this is just beginning to happen. So there's a huge upsurge of these kinds of threats that are beginning to happen. And this CFCA report is a pretty detailed report that has come from the telecom guys, and it just shows, it has a very nice summary of the different kinds of threats, from identity thefts to compromised PBXs to rate frauds. Financial credit cards that I mentioned about how Citibank lost 300,000 customers and they used a fake IVR to get the pins. Upsurge in botnets, toll frauds, all the different kinds of threats that is just growing by the number. So this is one of the customer networks. Just imagine this. This is the network activity in the secure MPLS network of an ITSP, and just in a matter of 3 days, we were able to get about 80,000 different alerts, all alerts coming from different locations, unique incidents, ranging from SQL injections to DOS, DDoS, to protocol fuzzing, to blacklisted locations, to split activities, to toll frauds, and again, nuisance traffic. Nuisance traffics are usually like, reconnaissance in terms of trying to understand the network. So it just shows that, the threat level has gone up big time just in the matter of the last 6 months. And this is just a sample. Didn't want to go into a lot more detail, but just in the sample of, just to give you an idea of the threat categories, like, categories from fuzzing to eavesdropping, where you can pattern tracking, to number harvesting, to voicemail reconstruction. You can actually reconstruct a voicemail. There's a way to retrieve voicemails, get into a WAV file. There are tools that you can modify the WAV files, inject RTPs into it, and then again put it back into the voicemails without anything knowing about it. So these are the kinds of attacks that can happen. Interceptions and modifications, call black holing. This is where you create a black hole. Any calls going into it are redirected to go to the black hole, like a honeypot server, and then you do postmortem analysis on that. Toll fraud, identity thefts, registration floodings, user class floodings. Tools out there from Nexus, SIPScan, SIPP, Civus. The different kinds of, all these tools are public. The large chunk of these tools are publicly available that you can do, and some of them are also homegrown and production oriented. So one of the talk that was addressed earlier was this cross-site scripting. Now you may wonder, why is cross-site scripting relevant in a VoIP SIP environment? Actually, it does. One of the vulnerability, I think on Asterix, about less than 18 months back, there was a packet where you could inject SQL injection into the SIP header, and it would force the Asterix to retrieve all the usernames with their extension. So username Joe with extension 800, all could be done with a very carefully crafted SQL injection. And I think it was fixed. It was fixed a lot then, but it just shows, because of data and IP convergence, a lot of malicious activities that are predominantly known on the data side can also affect your VoIP environments. And unless the DPI-ness of the voice streams are to the same level that you would expect, it's very hard to find these kinds of threats and attacks. I hope I'm not, there's a lot of content here, but just wanted to quickly show the breadth and the depth of the problem set around this category. We may not have time to go into the details of each one, but I'll try to broadly summarize the categories. Okay, so what I'm doing now is each of these threats, I'm breaking down into an architectural problem set. Architectural-wise, what does it imply? Now, why are we seeing so many threats? We mentioned that VoIP and UC is not just the PBX, right? It's the PBX with the whole UC servers, and then not to mention the data servers too, the data side, which is your web servers, your SSH, your FTP, your email. They're all interacting with your PBX and in a complex way. So what does this imply? It implies that the stacks at which you need to examine are a lot more thorough, need to be a lot more thorough and complex. So you could have an SQL injection from your SIP stream all the way to your database, and it could retrieve your user records. That could be one attack, right? Or it could be a weak policy control on your TCP UDP from which a botnet can go into your SIP servers and then do a vulnerability attack, right? Or it could be signaling to a media, or it could be your PBX modules, or even higher, it could be your UC application modules, then business services on top of it. So the arrows that shows where a threat can start from and where it can end. So it just shows that it is not a one dimension or a one vector component that you need to worry about. There's a lot of different vectors, a lot of different ways of how one can inject itself and then cause havoc on the other side. So this is the so taking this as the thesis, and then coming up with the broad threat taxonomies, where we think are the major broad categories that you as a business owner of this network need to be concerned or worried about, is make sure that device and OS vulnerabilities are because ultimately VoIP and UC systems run on devices and devices run on OSs. So OS vulnerabilities need to be patched, and you need to make sure that they're always up to date. Device configuration weaknesses. So devices, I think one of the One of the scenario was, most of these phones have a default web interface, and the web interface is usually through an HTTP port 80 with a default password that you can Google and get into it, and then you can get into it. So all of those, and then from there you can inject shell code across that scripting code through your post HTTP into your SIP stacks, and then create any kinds of things that you would care about. Similarly, IP and TCP, so we all know that it's, SIP runs on top of TCP stack, so we need to make sure that they're also protected. Protocol implementation vulnerabilities, eavesdropping, interceptions, fuzzing, denial of services, any kinds of manipulations, any kinds of media manipulations. Because unfortunately, media is a much trickier problem, because media is stateless, unlike signaling. Signaling has states. The TCP makes sure that states are rebalanced on both sides. To a large extent, simple naive man-in-the-middle attacks are less easy to do on a TCP than on a UDP stack. And so you need to make sure that there's a tight correlation between your signaling states and your media states. Only allow the media traffic for which there is a signaling negotiated traffic. So any kinds of unwanted ports, unwanted traffic, you just should block it right away. Infrastructure threats, I'll go a little bit more detail on that. Application layer threats, and then of course data to voice threats, and then voice phishing. So these are kind of like the broad 16 threat categories that we have identified from our research in terms of that one need to be aware of when you're a business owner of this network. So I'll go into a little bit more detail on each one of them. So device vulnerabilities, we all know, right? So all these devices, IP phones, endpoints, call managers, they all run on OSs, and OSs we all know, Linux, Windows, you name it, they're all lots of vulnerabilities. So you need to make sure that, unfortunately, real-time networks demand that you need to be on top of your vulnerabilities day -1, not day 0, day -1. On the data side, web problems can happen. Webs go down all the time, but it doesn't affect your business as such, unless it's a web-facing business. But unfortunately, your voice and phone networks are a lot different. So you need to make sure that you're on top of all the vulnerabilities, or at least you have a solution that ensures and guarantees that it is a complete zero-day protection on that front. Device configuration weaknesses, I talked about it, which is essentially, from our experience, we have seen that 50% of the problems are threats or attacks or nuisance traffics or abnormalities or frauds coming from the outside, but a good 50% are also suboptimalities from the inside. Human errors, ports that should be open, or servers that are infected by Trojans doing SIP botnets that they were not aware of because they didn't have the visibility at those layers. So all these combinations of things just shows that the technology is relatively immature. It's still in that process. Like, if you look at web firewalls, it took about 10 years for the whole stacks and technologies and applications to mature to a point where business applications can run on it. And we're somewhere in the first quarter or the second half of that journey in terms of the overall maturity in the process. So we talked about IP TCP, which is very well known. So I will not talk about this. Now VoIP and UC protocols are SIP, Skinny, HTTP3, RTP, XMPP, MSRP, TIP, VXML. So a lot of different protocols. They vendor different protocols, and we need to make sure that all these RFCs are less than a year or two old, very mature. We ran protocol fuzzers on commercial PBXs, and we were able to reliably crash them. So we actually identified Cisco's of several zero-day vulnerabilities in their PBXs, and they have credited. So it just shows that there's a lot of different problem sets that can happen. And just by running a simple automated, malicious scripts, all it does is inserts junk characters or junk buffer overflow meta characters into the SIP streams, and the PBXs will just choke in that process. Eavesdropping, we talked about it. So these are different kinds where, you do a buy, you can do a sell. Examples are like call pattern tracking, traffic capture, message stealing, message tampering. So a lot of different ways of, you can happen. Interception and modification would be like a toll fraud, where you're actually intercepting an incoming genuine call and then doing one of many things. It could be hijacking, rerouting, alteration, impersonation, toll fraud, user fraud. So on these frauds can all be at different layers. It can be at the network layer, it can be at the application layers, it can be at the user layers. So it's a pretty complex problem by itself to address. Fuzzing attacks, we talked about this. These are all commercial tools, Proto, Civus, Codnomicons, all these tools, they run about millions and millions of combinations, dictionary-based combinations of bad elements into the SIP streams. And unfortunately, many commercial solutions today are victims of these kinds of solutions today, or stacks today. VoIP media and UC denial of service. So denial of service, I talked about it, right? So denial of services could be one of two kinds. It could be resource starvation or resource unusable. And this is a very subtle difference between the two. Starvation is usually when you have a large volumes of traffic coming in and to the point where you're essentially choking the system by itself. And existing solutions are pretty good to address these kinds of things, unless, for example, if you have a presence flooding. You got mail, you got mail, you got mail. We actually have crafted attacks where you can actually show you got mail, you got mail, you got mail, you got mail, or you got message, you got message. Or somebody's presence states being flooding into yours because you were in the buddy list of that friend. So we actually got into the buddy list of the client, and from the buddy list we inserted a massive SIP refer. So the SIP refer would then parse the buddy list and then refer it, and then all your buddy list will get spammed by spurious messages. It could be one of many things. So it just shows that the combination of the application states that one need to monitor is much more complex than your traditional single session checks. Signaling threats, this is again, the signaling protocols, if not properly authenticated, encrypted, and without proper authorization, can result in several threats. So a lot of bad elements already out there in the world that they can automatically identify in your network what are the VoIP servers, what are the UC servers, what ports are open. Not only that, but also what version of the product it is, what vulnerability level it is, it patched, not patched. So it helps to create a very carefully crafted exploit to get to those to exploit that specific customer's network. So there is a dictionary of vulnerabilities matching to a specific set of a vendor list for which a carefully crafted messages are created, often through automated means. And in a matter of few minutes, you quickly identify it is Cisco's x.y.z patched to so-and-so level, and it's vulnerable. It is vulnerable to exploit x.y.z. So that helps me in creating a specific exploit to go further. Number harvesting, call pattern tracking, authentication cracking. This is another very interesting tool. Authentication cracking. So a lot of the have vendor default passwords. So using a dictionary-based tools, once you get Bob's number mapped to an extension 123, you can create a request, and based on the responses, we can quickly identify what is working, what is not working. And all of this are usually precursors to like toll frauds or identity thefts, or larger scale patterns that can happen beyond that. Now, media threats. This is just a few samples. Media could be from eavesdropping to replay to hijacking to tear down. So I can tear down a media conversation. Now we have shown, like when you have two live media conversations, just by identifying the ports and certain signaling headers from the signaling shake, I can tear down a live conversation. Let's say a CEO with a board conversation. I can just cause a very low volume denial of service packet for that specific sensitive conversation only, and this is very hard to detect. So spam over internet telephony, we talked about it. It's very easy. It's much more easier now than in your TDM world, because in the TDM world there was actually a human involved on both sides, where he had to physically call the numbers. But in the IP world, it's simple computer script. I can automate the extensions, and then I can create a wave attachment, and they just flood all the network that I can care about. Infrastructure threats. This is again, infrastructure here includes voice, media, IM, web, UC, and collaboration. So it touches a lot of different stacks, protocols, and components in your network. Unfortunately, voice, media, UC, it's a much more challenging problem than, say, only email or only web or only antiviruses, because the problem set is much simpler, it's more focused. But unfortunately, because of the way the usage paradigms are, you have thin client, smart devices, directly powered from the cloud with rich UC services, all touching different components. So in terms of the security posture, it's a lot more complex and detailed. Just go into a little bit more detail. So application layer threats, again, this is all at the application layer. So if you look at presence, I'm illegally manipulating somebody else's presence through buddy lists or unauthorized presence states monitoring. So hey, I'm looking at CEO if he's online, offline, or busy, and depending on the states, I can then allow me to do one of many things, right? So I'm actually tracking that. And how do I do that? There's a request that I force myself into the watcher authorization of that specific individual whom I want to track. And so unless you have controls to, like a whitelist controls, to only allow the genuine authenticated candidates to be in that watcher list, anything can happen, right? So there's a lot of these different scenarios like that, email spams and voicemail systems, illegally joining and leaving. So, you're having a sensitive conversations, somebody can force a request to illegally join somebody else into the conversations without you knowing about it. Especially with a lot of these collaboration elements touching different nodes across geographies. It's a very hard problem to solve. Data to voice threats, this is, we talked about buffer overflow, SQL injections, cross-site scripting, or command injections. This is a common problem that we have all dealt with the last 10 years or more. Voice phishing, I gave you this example earlier about how a fake bank was involved where a user was able to get the keystrokes. And this is just a sample, on the vulnerability side. So it's just not the threats. There's also the huge vulnerabilities that's going on. Now we are tracking every month. Cisco, Polycom, Avaya, they are releasing 15 to 20 new vulnerabilities every month. So that's serious. That's huge. That's really huge. That really shows that the stacks are not mature enough. What happens is a lot of these stacks were legacy stacks that suddenly got exposed to rigid IP environments because of the way SIP trunking and because of the way how the IP is being used to leverage these kinds of paradigms. It just exposes a lot of different vulnerabilities. So if you look at one of the example here, SIP proxy server implementation may accept replayed credentials in a call setup request, potentially allowing an attacker to reuse the credentials previously captured in the message of a choice. So unless you maintain states and unless you track session states to users to authentication credentials all in a proactive way, it's very hard for you to identify what is a genuine traffic and what is not a genuine traffic. So that's one side. The other side that I wanted to also touch upon is compliance and enforcement are also catching up, right? So yeah, that's fine. I have three more slides, I'm done. So we have SOX, GLBA, HIPAA, PCI DSS, FDIC, CALIA. So if your business is affected by any one of these compliance enforcements, you need to make an extreme sensitive survey and an independent analysis of your network to make sure, because each of these enforcements touch upon a different elements of the security posture, and you may not want to address all of them, but if you're doing credit card related bank authorizations using SIP, then PCI DSS might be an enforcement that you need to worry about. And I wrote a paper on this, essentially what does it mean for VoIP. This is just a snapshot of it. I'll be happy to share the paper. So what it essentially the paper says is, what is the effect of these compliance standards on a VoIP UC network, and me as a network or a business owner, what do I need to do step-by-step methodologies. This is just a snapshot of that. I don't want to go into detail of that, but that's essentially, I'll be happy to share that paper in a lot more detail. So in conclusions, this is the last slide. IP voice, video, and UC applications, they will continue to leverage IP infrastructure to empower rich user experience. The real mantra is across any device, any IP, and from any location. The stakeholders, of course, must understand that while this presents great promise, there are some unique security challenges that need to be addressed. And due to the real-time nature of properties of this, not to mention complex interconnect with many entities, many applications, many users, devices, the threat exposure is alarming. And it's important to consider this through the entire life cycle, not as an afterthought, and we need to understand the threats thoroughly. Hopefully in my short presentation, I was able to quickly touch upon a lot of different problem sets. Unfortunately, we didn't go into a lot more detail, but this has been at least from our research that we found.